For the reactions of aldehyde and ketone and halogen alkanes, all of them reacting with HCl or KCl. By reacting with HCl or KCl, you will find that they will form nitrile group, COH with another C with M. This is called nitrile. After that, by making reaction for nitrile, if we make reduction for nitrile, it will change into amine, RNH2, this is amine. If we make the reaction with HCl and H2O or diluted H2SO4, it will form carboxylic acid. Then, this carboxylic acid, if it reacted with concentrated sulfuric acid, it will form alkene with carboxylic acid, C double bond C reacting with COOH. Then, by reacting with potassium manganate, called potassium manganate, this is called diluted potassium manganate, it will be diol. So it will be COH, COH, then COOH. If we made heating under reflux, in the presence of potassium dichromate, it will change into CO with COOH, COOH, dicarboxylic acid. So again, the reaction of aldehyde or ketone or halogen alkanes, all of them reacting with HCl or KCl to form nitrile. After that, by reduction, it will form amine. If we made by the reaction with HCl with water, diluted HCl, or diluted sulfuric acid, it will form carboxylic acid. This carboxylic acid, if reacted with concentrated sulfuric acid, it will form alkene with carboxylic acid. Elimination reaction. After that, if reacting with diluted cold potassium manganate, it will form diol. So to form OH, OH, the double bond will be single and then OH, OH will be added. And then if we make oxidation for alcohol, it will form acid. So OH and OH will be COOH. In map, the general map, you will find that we have alkanes and halogen alkane and then we have alkene, alcohol, aldehyde, ketone, carboxylic acids, and then ester. For alkanes to alkenes, this is by cracking. Then returning back by addition of H2. For alkanes to halogen alkane, by reacting with X2. X2 means like Cl2, HBr2, or any like this, any halogen, X2, to form halogen alkane. And in case of alkene to halogen alkane, by addition, but this substitution is by addition of X2 or HX, like Cl2 or HCl. And then, by adding water to alkene, this hydration forming alcohol. Alcohol returning back by dehydration or elimination reaction. After that, for alcohol, if it's primary, it will be oxidized by potassium dichromate to form aldehyde. Secondary, to be oxidized by potassium dichromate to form ketone. And for complete oxidation, can be formed directly. This complete oxidation by K2Cr2O7 for primary to form carboxylic acids. This heating under reflux. But this in case of distillation, incomplete oxidation to form aldehydes. And then aldehyde by oxidation can be returning to carboxylic acid. By oxidation of aldehyde, potassium dichromate to form carboxylic acids. And then carboxylic acid can be returned back to alcohols by reduction. This by oxidation and this by reduction. So the reduction of carboxylic acids by using LiAlH4, returning back. Then the halogen alkanes, aldehydes, and ketones, they are reacting together with HCl or KCl to form nitrile. This nitrile to be oxidized or before oxidation, it reacts with diluted H2SO4 or diluted HCl to form carboxylic acid. And then this nitrile can be reduced to form amine. To form amine. For halogen alkanes to be alcohols, if we're reacting halogen alkanes with H2O or NaOH aqueous, it will change into alcohols while returning back from alcohols to halogen alkanes if reacting with BCl5 or HCl or SOCl2 or Bi3, in one of them. So in case of going from halogen alkanes to alcohols by reacting with H2O or NaOH, aqueous must be aqueous, because if we're reacting with alcoholic, it will form alkene. So for halogen alkane to change into alkenes, it must react with NaOH alcoholic, but in case of NaOH aqueous, it will form alcohol. In case of adding potassium dichromate to alkene, cold, so in adding diluted cold potassium manganate, it will form diol. While if we adding concentrated hot potassium manganate, it will form carbon dioxide, or it can form another compounds, primary alcohol, to form aldehyde or to form ketones. So it will form CO2 or aldehyde or ketone. In case of C with two H's, it will form CO2. If it contains CHR, it will form aldehyde. If it contains C with two R, it will form ketone. And for ester, you will find that alcohol and acid reacting together to form ester, and by hydrolysis of ester returning back to be returned by hydrolysis. Technical reactions of acidified potassium manganate. Acidified potassium manganate in case of cold and diluted. These four alkenes, C double bond C, it will produce diol, OH, OH. In case of hot concentrated, it will produce, it depends on C double bond C. If it contains two hydrogen, so it will produce CO2. If it contains CH and R, it will produce aldehyde, then acid. If it contains C with 2R, it will produce ketone. And in case of potassium dichromate, and the color of potassium granate, it changed from purple to colorless. While in case of potassium dichromate, orange to green. In case of primary, it will form aldehyde, then carboxylic acid. Primary, it means that it contains CH2OH. Secondary, CHOH. It will form ketone. Tertiary, COH. No reaction. After that, for alkane and alkene, bromine water. Red brown to colorless. In case of alkane, no change. In case of alkene, it changed from red brown to colorless. Reactions of aldehyde and ketones. By using 2,4-dinitrophenylhydrazine, it means that it is aldehyde or ketone will react with both and to form red or orange precipitate. And this testing for carbonyl group. After that, total reagent. It will form silver mirror. In case of aldehyde, no reaction in ketone. Failing reagent. It will form red precipitate in case of aldehyde and no reaction in ketone. In case of iodoform, it will form yellow precipitate and no reaction in ketone. So this reaction tests for ketones. And the other two reactions test for aldehydes.